Hi students and family members, welcome to our unit on division. Answering this first question first. How do we divide? Well, before we even get there, we have to know some key vocabulary in the sense of division to make sure that we understand what we're doing when we do eventually divide. So how do we understand division? We need to understand the vocabulary that goes with it first. Let's take a look at some key terms that will pop up throughout this entire unit. The first word is divide, which in simple definition is a large group that is separated into smaller and sometimes, but normally, equal groups. This picture represents a total number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the large group we're talking about, and it is divided equally into 1, 2, 3, 4 groups of 3. That's what division is basically doing, taking a large group, in this example of 12, and separating it into equal groups. Another example of things that get divided would be something very tasty to eat, a bag of Skittles. We can separate a bag of Skittles between 5 people like seen in this example here based on the colors red, orange, yellow, blue, and what looks like purple. So we have 5 different colors, and they get separated because of the Skittles bag. A non-example would be multiplication. Multiplication would be taking the Skittles and then giving multiple bags or increasing the number of Skittles that you have in each group. This is the definition of divide that we'll refer to throughout the entire unit. Now, when we get into an actual long division problem, this is what we're going to see, like the picture right here on the right. This is an example of a division problem, a typical division problem. We have a divisor, and that's the first vocabulary word in division that we're going to talk about when it comes to long division. A divisor is a number that divides into another number, and this is generally the smaller of the two numbers in a division problem. So I have the number 16 in my picture example here, and the number 3. So which one is my divisor? It's going to be the smaller number that is dividing into 16. Here's a picture example. When I have 10 divided by 2, the divisor is the smaller number, this number 2, and that way you can see these apples are separated into 2. If you can't see that, let me make it a little bit bigger so you can see there are actually a pair of apples sitting on a small plate in each. A non-example would be the dividend, which is our next vocabulary word. The dividend is the larger of the two numbers, the one that goes inside of this long division box. By definition, the dividend is a number to be divided or separated by another number. This is the larger of the two numbers again. So if I'm looking at this array here, I have 1, 2, 3, 4 groups, 1, 2, 3, 4, 5 rows, which means I have a total of 20. So in my picture example, my dividend is the total or larger number that is being divided. 20 is the dividend, and depending on how many groups we separate that into, that is what is being separated. A non-example would be the divisor, which we again know is the smaller of the two numbers that is dividing up the dividend. Our quotient is the answer when dividing numbers, the answer to a division problem. This is similar to when we multiplied and we had a product. The product was the answer to a multiplication question. The quotient is the answer to a division question. So here's a picture example. I have 30 being divided by 7. Again, my divisor is going to be the smaller of the two numbers, or the 7. My dividend is going to be the larger of the two numbers. And now when I finally get an answer and I find out, well, you can break 30 up into 4 equal groups of 7, 4 is my quotient. That is my answer when dividing up this equation. I do have a remainder in this example, but we'll get to that in just a little bit. Here is an example again. The example answer would be 4. The 4 is my quotient. This is a non-example. Because I'm multiplying, I do not get a quotient. I get a product. This, number 9, is the product of 3 times 3. This, number 4, is the quotient of 12 divided by 3. I mentioned remainders in the previous example. Notice in the quotient, I have an R and then the number 2. That's because 30 cannot get divided equally by 7. You can put groups of 7 into 4 equal groups, but then there are still these 2 left over. When you have a remainder, that's what's left over. So in this case, it's the leftover. You can tell I have an incorrect definition here. That is, whatever is left over in a division problem. So in my picture example here, which goes back to that original picture I saw, I have a divisor, the smaller of the two numbers, the dividend, the larger of the two numbers, that is being separated, and then I have my answer or the quotient. My remainder is whatever is left over. In this case, I have 2 equal groups of 4 with 1 cookie left outside. That's my remainder. Equal groups would be a non-example. If I had 5 divided by some number, I'm going to have a remainder. However, if I had 15 divided by 5, I would have equal groups and no remainder. Now, a couple other definitions that we need to consider in division are a bit of a review from multiplication definitions, because multiplication and division are kind of related, even though they're the opposite. We know multiplication is making things larger and division is separating, making things smaller. But still, we need to know fact families and the next definition, which will come up. The definition of a fact family is a collection of related addition or division or subtraction or multiplication problems made from the same exact 3 numbers. Here's my picture of an addition-subtraction fact family with 10, 7, and 3. We know that we can have 4 number sentences that are going to get me the same exact answers. 7 plus 3 is 10, 3 plus 7 is 10. That's the commutative property of addition that tells me that that works. 10 minus 7 would get me 3, and 10 minus 3 would get me 7. Here's an example of a fact family using multiplication and division. We'll be focused more on the bottom 2 number sentences here in our division unit. The larger number is normally what you start with in a division number sentence, because you're taking again that larger number, that dividend, and using the divisor to separate it into your quotient of equal groups. 12 divided by 3 is 4 with no remainder, nothing left over. 12 divided by 4 is 3 with no remainder, none left over. And when we have a fact family, we can not call it an array, which is just a picture representation, as we had learned from our last unit. This is the definition of a fact family. The other thing we will also be considering in our division unit is bar modeling. It's a picture using bars to help us solve a word problem. I've also been introducing to the students that when we are solving the word problem using these bars, typically the bars represent the K, or what we know. The W is what we want to know, and then the number sentences that we come up with to solve the word problem is the S, or how we are solving the problem. And that's the attack scheme that we have for word problems. What we know, what we want to know, the question, and then how we solve it with number sentences. So hopefully understanding these definitions will help us understand how we divide in this unit. Talk to you soon.